In this session, we'll discuss what do you mean by the synchronization or the parallel operation for alternators, what is the necessity of the parallel operation, and the conditions for connecting the two or more number of alternators in parallel. That is, the parallel operation is connecting an alternator in parallel with another alternator or with a common bus bar is known as synchronization. Connecting, that is the alternator to another alternator or to the bus bar is known as synchronization. Then comes what is the necessity of the parallel operation or advantage of the parallel operation, that we'll see one by one. One is the first advantage of connecting a smaller units in parallel is the continuity of the supply and the maintenance. That is, a parallel connection is more favorable for repair and periodical maintenance work. It is easier for maintenance when the smaller individual generating units are used, since we can schedule the maintenance of each unit one after the other without affecting the continuity of the power generation. That is, just I will take a small example. I have got a load of the 100 kVA. I have got a load of, you can take in the with the power factor, that is 100 megawatt is the load. 100 megawatt is a load. Suppose I am using 10 megawatt unit of each 10 numbers I am using for supplying this load, that is 10 units. Then it is a catering needs of 100 megawatt total load. Suppose if you are using only 100 megawatt unit, then the anything happens to this or it is come for the repair or a maintenance, then the whole unit, the whole supply is cut down. Then there is no continuity of the supply if you are using only 100 megawatt. Instead of that, if you have got 10 units, they are connected in parallel. If you want to take a maintenance for any one of the unit, then the rest of the units they are supplying the load. Then you can take the maintenance for this. Then after maintenance, you can go for the second one. You can up this and you can take it for the maintenance. Means it is very easy for taking for maintenance, as well at the same time there is a continuity of the supply you are getting if a smaller units are connected in a parallel rather than a single unit. That is the first advantage. Okay. The same thing is written here. Therefore, if instead of it was a single unit, then the entire shutdown would be required for maintenance. This would drastically affect the power demand during the duration, that particular maintenance duration. That is, if you are using a smaller unit, can one by one you can take it for a maintenance without disturbing the continuity of the supply. Okay. The next advantage is that it is expansion planning. The expansion planning means, suppose at present I have got a load of 700 megawatt or 500 megawatt. It is given in this example. That is, I have got a 700 megawatt of load, 500 megawatt of load now, right now. Okay, present I have got 500 megawatt. Suppose you are using a single unit of 500 megawatt, equivalent to that, a single unit. Subsequently, after 2 or 3 years, the load is grown to 700 megawatt. Then it is not possible to cater the needs using a 500 megawatt because the load is increased to 700 megawatt. Therefore, what you have to do? You have to scrap 500 megawatt. Then you have to go for the 700 megawatt new version of the unit. Then it is not possible to, if there is an increase in the load, it is not possible to enhance the existing 500 megawatt to 700 megawatt. Okay, therefore you can scrap and you have to go for another 700. Instead of that, I have got 100 megawatt 5 units. I am connecting in parallel. It is cater the needs of 500 megawatt. Subsequently, the load is grown to 700 megawatts. 700 megawatts. Already 5 units they are catering the needs of 100 megawatts plus 2 more units of 100 megawatt I am adding. It is added. Therefore, we are getting 700 megawatt total. Then it is very easy for expansion planning. In the case of a single unit, then you have to totally replace the whole unit. That is not the economically feasible. Okay, that is why it is written as suppose the current capacity of the power plant is 500 megawatt. In order to expand the capacity of 700 megawatt to fulfill the rising future demand, it would be costlier to replace the entire setup and purchase a bigger unit. Therefore, if the smaller units are connected in parallel, as and when there is an increase in the load, that can be met using adding the smaller units in a parallel. Then it would be more economical to buy a small individual alternator units which can be added in parallel to the bus bars system in order to reduce the initial capital investment. That is the advantage of the connecting the alternators in parallel. Then the third advantage is that size of the alternator. That is, if you are having the load of equivalent to 100 MVA, then if you are or 1000 MVA, then if you are designing 100 MVA alternator to cater need of 100 or 1000 MVA load, then it is a bigger unit. The size of the alternator is very big. Then there is a problem of transporting. That is, we know that the power stations, they are located in where there is a resources are available in the remote places. As such, there is no a proper connectivity to those power stations. Then in that case, if you are designing a single unit, then it is a very huge size and the transportation problem is there. Instead of that, if you are using a smaller unit of 100 MVA with a 10 units, that is, it is catering need of 1000 MVA. That is more convenient than a single large unit. The same thing is written here. The higher the rating of the generator, the bigger the size of the setup. It is very difficult to manage a single large unit which may be range around 1000 MVA or more. We are using small individual units connected in parallel. It will be easier to maintain as well as considering its size as well as the transporting to the requisite site. Then the next advantage is that increase in the reliability. That is, the reliability of the power system increases if any of the machine fails to work, the other alternators will continue their working to supply the output to the system. I give you the example. If you have got a 1000 megawatt of the load, then if you are using 1000 megawatt alternator to cater the need of 1000 megawatt load, in that case, what happens? If anything happens to the machine, the whole supply or the supply system is interrupted, then it is not reliable. Instead of that 1000 megawatt load can be supplied with 100 megawatt 10 units. In that case, any one of the alternator goes into out of order, then at least the remaining alternators, they are catering the needs of the demand. At the same time, and the standby unit is added to that one, and we are getting the 10% the reliability. Okay, that is more advantage by connecting the smaller units in a parallel. At the same time, the cost of the standby unit, that is, we are taking a size of 1000 megawatt load, 1000 megawatt alternator, the cost is more than If anything happens to that 1000 megawatt alternator, that is for continuity of the supply or for more reliable power supply, then one should have a standby unit of a same capacity, that is 1000 megawatt. Then the cost of the standby unit is increasing. It is very high value. Instead of that, for same 1000 megawatt load, I have got 100 megawatt 10 units. Suppose subsequently I want a standby unit. The standby unit can be equivalent to a single unit, that is of 100 megawatt size. Therefore, the cost of the standby unit, if the smaller units are connected in parallel, then the cost of the standby unit is very small as compared to the cost of a standby unit of the higher capacity. The same thing is written here. The large alternators makes high capital cost instead of buying a smaller alternators and connected in a parallel operation. Then the advantage of the connecting the alternators in parallel is efficiency. Then if you are using a single large unit for a lesser load, for example it is 100 megawatt one single unit or 1000 megawatt one single unit, the load is around 700 megawatt. The capacity of the alternator is 1000, then your load connected is only 700 megawatt. In that case, the efficiency of the alternator is less because you are not loading that 1000 megawatt alternator with its full extent. Therefore, efficiency is less. Then it is not the advisable for a smaller loads a bigger unit. Instead of that, if you have got a single units having the smaller capacity of 100 megawatt 10 if you are using, in that case if your load is around 700 megawatt, then I am running only 7 units, so that is a catering needs of 700 megawatt, so that all the alternators they are operating to its full extent. Therefore, at the same time the efficiency of the system is also efficiency of the whole the network is very high. Okay, that is why it is also play an important role in the efficiency of the alternator. That is, according to the efficiency versus load curve, generator efficiency is maximum when the load is 100%. So the generator unit must run on full load. A single large unit would be uneconomical for lower loads, but with the smaller individual units, we can add up or switch off the generator units as per the load requirements in order to meet the maximum efficiency. These are some of the advantages of the connecting the alternators in a pair. Then, what are the different conditions we have to fulfill to connect the alternators in parallel? Okay, there are certain requirements which must be fulfilled before an incoming alternator can be put in parallel with the existing alternator. This is called as synchronization. The first condition is that the terminal voltage or effective voltage of the incoming alternator is same as that of existing alternator or a bus bar. If you are connecting to another alternator, then the incoming alternator voltage, that is the terminal voltage, is same as the existing alternator terminal voltage. Or if you are connecting the alternator to the bus bar, the alternator terminal voltage must be same as the bus bar voltage. That is the first condition. The second condition is the frequency of the incoming alternator. The frequency of the voltage of the alternator is equal to the existing alternator or bus bar frequency. First one is the terminal voltage must be same. It is same as either your bus bar voltage or the alternator already existing in the system. The second condition is that the frequency of the incoming alternator is also equal to the existing alternator or bus bar the frequency. The third condition is that the phase sequence of the voltage of the incoming alternator, that is R by V of the incoming alternator, is equal to the existing alternator or a bus bar the phase sequence of R by B. That is also important conditions when we are satisfactorily connecting the two or more number of alternators in parallel. The fourth one is the phase of the incoming alternator voltage must be identical with phase of the bus bar voltage. That is, this is another important condition. The phase of the incoming alternator means when if you are taking into consideration the alternator phases with respect to each other, they are opposing each to each other. However, when it comes to a common load, they are all the alternators, they are acting in the same direction. That is what you mean by the phase of the incoming alternator voltage must be identical with the phase of the bus bar voltage. These are the four important conditions you have to fulfill when you are connecting the alternators in pair.